If you can hear me clearly, right? Okay, so I want to welcome everyone to my let me just say midterm two preview today. I've decided to dedicate today and Wednesday for revision and the midterm two practice. Of course, there's going to be midterm two exam course this week. So I want you to sit back and, follow what we're going to be doing today because, I'm not going to be totally invariant, from what I'm going to be presenting today when it comes to midterm two. So I would like you to pay attention. Now, let me make this announcement. There's not going to be use of software, our software in midterm two. Okay, so I've reserved that for final when you're going to have, a lot of time. You get what I mean? So I'm going to repeat that again. There's not going to be, you're not going to use I'm not going to ask you to use a software, our software for the exam. So it's some questions just like what I want to present to you today. Maybe some of the code have been run for you, or what you just need to do is to answer some questions. Does that make sense, right? So I would like you to pay more attention to what we want to do today. It's very, very important, the midterm two practice. Okay, so of course that should be a mistake. I wanted to say midterm two. Okay, so the midterm two area of coverage, of course, I mentioned the other time, from two-way analysis of variance into ANCOVA. And of course, tonight, you're basically going to see your grade for assignment 6. The ANCOVA that will come in midterm 2 will not be complicated. I'm going to say that again. The ANCOVA that will come in midterm 2 will not be complicated. Of course, there's going to, of course, we take a look at the question this particular midterm practice, there's an ANCOVA. Maybe it's going to look like the way the one here is going to look like. Like I said, you are not going to make use of our software. Maybe some of the code have already been run. You're going to be presented with results. All you just need to do is how do you do justice to the result? Okay. Now, I'm going to start with problem number 1. When you take a look at problem number 1, a study was actually conducted, in guinea pigs to investigate the effect of dose of vitamin C, okay, and delivery method on the length of maybe endotoblast, which we call cells responsible for tooth growth. Data was recorded for 51 guinea pigs. The variables are, you have the dose of vitamin, and you have there are 3 levels of that: 0.5, 1, or 2 mg per day. And of course, there is this delivery method, the orange juice or ascorbic acid. Now, the researcher was actually interested in these particular levels, okay, analyze the tooth growth 2 data set to determine what factor maybe dose and or method affect, and you are asked to do that at 0.05 level of significance. Now, the data here has already been, they try to give you the, maybe the first 6 of in the data. Okay, you have a dose, you have the length, you have the method, and of course, Please, like I said once again, whether you're online or you're in person, I need you to pay attention to this. We are basically going to do this exam without you using any statistical software. But if you can follow me now with what I'm explaining, oh my God, you're basically going to score more than 100% in this midterm too. Okay, it's an opportunity for those who did not really get what they anticipated in midterm one to actually write what went wrong then. And that's why I need you to pay attention to me. The moment you don't really understand, you ask question. For those of you online, can you also confirm if you are hearing me clearly, those of you online? Can somebody confirm among the, okay, thank you so much. Thank you for confirming that. Now, two students, they run this analysis together. The name of the first student was Mickey. The second one was maybe mining or mini. Look at the first result, look at the second result. The results are not the same. Okay? The results are not the same, despite the fact they are actually using the two-factor from this experiment. Of course, this is a two-factor experiment because as you can, they were testing the effect of dose and the delivery method. So that make it two-factor experiment with interaction. Okay, now we take a look at this. You will see that the reason why they got different method, if you look at Mickey's results, the Mickey tried to use a method as a factor A, why Minis use those as a factor A. Now, in a situation where you compare the sum of square for Mickey with the sum of square method for Mickey and the sum of square method for Minnie, the two of them are not the same. In a situation where the two are not the same like that, then that should, tell you they must have used some balanced data. Does that make sense? Because if it is balanced, okay, whether they order it or not, whatever anybody use as a factor, the result will be the same. So this is sending a message. Of course, they are working with unbalanced data. Now the question now is, who is wrong between two of them? And that was why I said, since Mickey and the mini result did not agree, someone is definitely wrong, or even both are wrong. Then what are we now going to do to fix the problem? And I ask a question here. Of course, you already know what you learn in class. To fix the problem, I know you're basically going to use the analysis, the sum of square of type 2. But without doing nothing, I said, look at the question number 1. Complete the following ANOVA table with the correct result. Look at the hints. You do not need to compute anything at all. But it's like, if you look at the table, the interaction, the residual, I think they've already filled out for you. What they just need now is the dose and the method. But let me tell you this, without doing nothing, you will go back to these two results. You will pick the largest sum of square value. Now, compare method, sum of square method for Mickey's and sum of square method for Minnie. I want to learn from this. How do you call that? Is it Minnie or Minnie? Can somebody give me the correct pronunciation? I'm also learning that name. I'm calling it Minnie. Is it many or many? Can somebody tell me? Eh? Many, right? Oh, maybe I'm very close to being right? But I also want to, I my accent is my accent bad, right? I'm trying to learn. Okay, now you're going to compare the sum of square method for the two students. I mean, the two students that work this out. We're going to pick the highest between them. We're going to compare the sum of square those. If you take a look at what you're seeing in the table, when you compare the those, sum of square those obtained by Mickey and sum of square those obtained by Minnie, of course, that of Mickey is the higher one, right? We're going to pick the higher one. We're also going to do the same for sum of square method. Compare the two sum of square method. We're actually going to pick the higher one. Let's now go to the table now. Any question? I'm done. I'm done. Go ahead. That's a very good question. Somebody asks, why do I go for the largest sum squared? Because when you look at the definition of the type 2 sum squared, it's going to consider the first factor we have the largest variation. Does that make sense? It's going to consider the largest variation. Since two people run or two different analysis on the same factor method, somebody get 22.9, another person get 1860.8. We're always going to choose the highest variation. The variation here is not a negative one that you always know that, it is not all the time that the interest is going to be on reducing the variance. Do you know the variance we're reducing? It is the variance of residual, not the variance associated with a factor. What is our intention? In fact, our intention is to maximize the variance associated with a factor. The more the value of the sum of square, the more the variance for the factor. That is what we want. Does that make sense? So the one we always want to minimize is the sum of square that has to do with residual. But we want to maximize the sum of square that has to do with the factor. Because by factor, we're actually looking, we're looking at the variance, we're looking at the amount of variation, a particular factor contribute. If a factor has in one analysis, it contributes very small amount. In another analysis, it contributes a very higher amount. I'm going to go for the higher one. Have I answered your question? Have I answered your question? Okay. Now, without running analysis, I just put all results. But let me tell you this. There's something I wanted to say. I pretended. Oh my God. I pretended as if I run the analysis by trying to write type 2, because if you go ahead and run a type 2 test, this is what you're going to get. If you go ahead and run a type 2 test, this is what you're going to get. But you do not need to run a type 2 test, which means when you have an unbalanced data and you have used type 1 sum squared, if you have done that 2 ways, like if you have done that 2 different ways, where you have 2 factor and you decide to switch without running the ANOVA sum of square type 2, you can actually set up your table for what the result is going to be, just like what we did here, without running any analysis. You don't need to run any analysis at all. When you run an analysis, just for you to confirm. Any question? Any question? Any question? In this exam, I want the minimum student to be 100%. The journey starts now. the countdown start now. If there's any area that is not clear to you, ask me question. You pay for the service. Now I'm going to go into question number 2. He said, can the method dose, interaction be dropped from the model? There's several ways to drop an interaction from a model, okay, apart from looking at the p-value. In fact, type 2 interaction does not put into consideration type 2 sum of square does not put into consideration interaction, except type 3. You've done that in class, right? Theoretically. But the other reason, you take a look at the p-value associated with that. It's not even significant. And I said the data are unbalanced, so we can drop, the interaction, okay, to obtain a better estimate of the main effect. In an unbalanced data, estimate depend on what times are in the model. Therefore, it isn't desirable to have ns time remain in the model. We, of course, using the fundamental theory of type 2 sum of square, we don't consider interaction. And if it's even going to be insignificant. Okay, now question 3. Using the SS notation, if I were you, study this very well. You remember in class I was using XXA, okay, giving 1, XXA giving 1, comma B, stuff like that. This is for type 2 sum of square. Don't forget, when you go back to the table, we choose Mickey's dose, and we choose Minnie's factor method. Now, because of that, if you want to write the reason, this is the reason. Why do I choose, when you take a look at the reason, here they say using SS summation. So why is Mickey's method sum of square does not equal to the Minnie method sum of square? Because don't forget, when you're looking at the type 2 sum of square, when you look at the type 1 sum of square, the type 1 sum of square is going to give the first factor the largest allowable variation. I'm going to say that again. The type 1 sum of square will give the first factor the largest allowable variation, and that is why order matter when you are dealing with unbalance. If it is balanced, there's no problem. Order do not matter. But with unbalance, order do matter. The first factor we have the maximum amount of variation. So when you take a look at in the Mickey's method, okay, we know we're focusing on method, right? Mickey take factor A to be method, and Minnie treat method to be factor B in a model. Why Mickey take method to be factor A? And the reason, and you're going to see somebody sum of square, Mickey sum of square for method was 22.9. Why, Minnie sum of square for method was 280.5. And the reason is what I'm giving to you now. The one of 280.5, okay, that is for Minnie is because of the fact that if you look at the sum of square associated with that, okay, that is the sum of square for method after adjusting for the other factor dose, which means Mickey did not adjust for any other factor. Take a look at the Mickey's 1 sum of square method giving 1 means it just intercept. Is what is adjusting. Of course, everybody will adjust intercept, which is normal in every model. Every statistical model has an intercept. So take a look at that. I think in class I was using A, B. Okay. Now, the next question said, what type of model did the student fit? Is it fixed effect? Is it random effect? Is it mixed effect? Explain. If you go back, they did not tell us whether these were selected at random. the levels. They didn't tell us that. And they did not tell us they are interested in determining variability. They didn't tell us that. Those are the two things that may point towards random effects. But since they did not tell us that, then we're basically dealing with a fixed effect. So which means they only have 3 doses of vitamin, nothing more. And they got to the delivery method, nothing more. And that automatically qualify them to be a fixed effect model. Does that make sense? Now, what observation, if any, are correlated? Let me tell you this. When you are working with a fixed effect model, or whatever model, provided you are not, this is what happened. If I'm working with a fixed effect model, there's nothing like a correlation. It is only when we're looking at a random effect, because in the random effect model, okay, because the random effect, the random factor has variance. Okay, if any factor has a variance, there is tendency. We can compute the correlation. Don't forget, correlation is the ratio of the explained variation by that factor divided by the totality of the variance in the model. We only talk about that when we're talking about random or mixed effect. We don't talk about that in fixed effects. There's nothing like random in fixed effect. The only thing that is random in fixed effect is the error. Error is random in any model. So because of that, I'm going to say none. When I'm working with fixed effect, provide, we have the assumption that observations are selected using the principle of randomization. And the groups are whatever we're comparing are independent. Okay, that was why I said none. Now, that is the end of problem 1. I want to confirm to you now. Problem 1. I mean, don't let me say problem 1. A problem in your midterm will focus on the unbalanced data like this. So please take notes. Now, I want to go to problem 2. Problem 2 is a question on ANCOVA. I promise I'm not going to give you a complicated one like the one in the assignment, because I know you have a lot of time to complete the one in the assignment, but this is an exam of 50 minutes. Now take a look at this. I don't want to waste time. We got 3 levels of discounts, which make discount to be categorical with 3 levels. And of course, we got price and we got sales. Okay, but let me tell you this. They say the grocery store is actually, they're always interested in how well the products on the store shelves sell. Okay. An experiment was designed to test whether the amount of discount given on products affected the amount of sales. Automatically, the sales is going to be response variable here. And the independent variable that I call, is basically going to be a discount, which has 3 levels. But at the same time, price is also considered to be a potential factor. And this price is quantitative. Then you should be sensing that this question is going to be, it will be based on ANCOVA, because in addition to the categorical predictor, we also have a quantitative. Now, you know what? They've done a lot of stuff for you. I'm going to, it's at the back of this. They've run it. Look at that. Like I said, you are not going to run any analysis. You're not going to use our software in this exam. everything will be done for you. You happy, right? Okay, everything will be done for you. Okay, now take a look at this result here. We have some arrow apple here. The first one, looking at the effect of price on sales. Why is he investigating that? Or probably he want to see the connection between the covariate and the response, right? That is the reason why he's doing the first one. And he's just going to do a linear regression for that. Now that turned out to be significant. If you take a look at that, which means the covariate, okay, influence the response. That is one of the tests to investigate whether covariate, inclusion of covariate or considering covariate in my model is justified. Now, if you take a look at the price and discount, why am I investigating for the price and discount? What was the price? The price is actually covariate. It's more or less as an explanatory variable. And the discount is another explanatory variable, but it's categorical. One of the assumptions in the Ancover is that there shouldn't be any relationship between two independent variables. Of course, two independent variables, one categorical, the other one quantitative. And that's why when you take a look at the p-value associated with that, you can actually tell. But let me tell you this. If you look at the second one that said price on discounts and sales on discount, if you go back, okay, the predictor variable, give me 1 second. The predictor variable was actually, if you take a look at that, whether the amount of discount affected the sales. Sales is the response. Okay, I want to take note of that. Sales is the response. Now, if you look at the first one, sales, that is the response. We're looking at the relationship between that and the covariate. That is significant. Now, the second one is the price and discount. The price and discount, they are the two independent variables in the model. The price is the covariate. The discount is a categorical factor. There shouldn't be any relationship between them. That will be a second test for the covariate to pass. And what do you actually, so when you do that, when you investigate that, okay, now when you take a look at the sales and discount, okay, the sales and discount here is more or less like in model.2, you are not considering price at all. Why are you not considering price? Maybe you just say, maybe price is not, I mean, the price is not important. The covariate is not important. If I really want to, investigate a factor that affects sales, when I give discount, I'm fine. Of course, the model.2 is one-way analysis of variance, where you are only considering comparing the levels of discounts. How many levels of discount do we have? You got 3 levels of discount. And you basically want to see whether on average, the amount of sales is the same across the level of discount, neglecting the covariate. Now, the decision here is that there's no significant difference looking at the p-value associated with that. Now, you now incorporate covariate now. You're going to see that here, we're coming to something when we did not consider covariate. Now that we now consider covariate in the model, take a look at model.3. The model.3 is now when you relate the response variable cell to the discount and adjusting for covariate now. Okay, Now, this is what we have. Initially, do you know the discount was not significant when you did not consider covariate? Do you see that bottom one? 0.569 indicates no significant. The discount was, if you are focused on this only, you would have misled the outside world. You know why this cannot be trusted? This cannot be trusted because an important variable is missing, and you did not account for that important variable that is missing. Even if you give discounts, what about your price? And that is the reason. Take a look at this guy now. By the time you now run the anchover now, you can now see the discount is significant and the price is also significant. But how am I going to know if the anchover work? I can compare the mean-square error. I will compare the mean-square error. So in fact, I know they're going to ask that question too. Let me quickly go back to what we're doing. You know, today I only want to do problem 1, problem 2. On Wednesday, I'm going to do problem 3, problem 4. Does that make sense? I don't want to rush you at all. Now, this is what I'm trying to say. Now they gave you this. Your response should be a logical flow of the steps you will take to arrive at your final model and what decision you made at each step based on the output. The output that I showed you the other time. Okay, simply writing down the final model with gain few points, if any. Remember, your goal is to address the question of interest, which is whether the amount of discount given on the product affects the amount of sales of that product. Let me tell you, the main primary variable of interest is looking at the effect of discounts on sales. But along the line, we now say, okay, maybe there exists another factor that could influence sales, and that was why we're considering price. Okay, so all this is just interpreting what I just showed you the other time. Okay, now problem 2 now said, is the ANOVA model a better model than your final ANCOVA model? Do you know what they want from you? Anytime they ask this question, oh my God, what do we compare? When we're comparing models in statistical analysis, then we're actually going to compare the mean square error. I'm going to say that again. We compare the mean square error of the two models. The one with a smaller mean square error is basically going to be a better model. What I needed to do, you go back into when they did not consider ANCOVA at all. Okay, take a look at that. Model dot 2. Do you see model dot 2? There is no covariate. Okay, they will look at the effect of this kind of sales. What is the mean square error here? The mean square error here is actually 1123.5. Now that we now consider covariate, okay, now that we consider covariate, what now happens when we consider covariate? Oh my God, considering covariate now, the mean square error has drastically reduced to 26. Is there anybody here who is not seeing that 26 on the board, where you have a mean square error? So which means, according to efficiency property of an estimator in statistical theory, when I have two estimators, the one that is more efficient is the one that have a lower variance, the one with the lower mean square error in case of bias. So, and that is the reason why we're trying to, okay, you're going to see what my response was. When I actually answer that, you're going to see what I said. What was my response? I said The Ancover model is a better fit to the data as the mean square error reduces from 1123.5 to 26. You know, when you tell me the Ancover model is better without telling me the reason, you are not going to get a full point for that. Because if you are telling me that, I'm actually going to see you as a judge who said, I've committed an offense without telling me the, what is it called? Without telling me the offense that I committed. Of course, before you send me to jail, you have to tell me the what I've violated. So before you can take a decision here about which one is a better model, then we have a model selection criteria that we actually call mean square error. And the one with a lower mean square error is a better model. Any question? Any question? Are you getting your confidence back, right? Okay, I can see you're getting your confidence back. Okay, now, question 3 now. For your final model, see, for your final model, of course, you've chosen Ancover. Why have you chosen Ancover? Because you've been able to justify the inclusion of the covariates, price, play a huge role if I basically want to predict the volume of sales. It is not only discounts. Look at your price too. You know, it's just like somebody who sets a very high price. And that's okay, I'm giving you a discount. Even when you offer that discount, the final price with the discount is even higher than the one I can get somewhere. It's even higher than what I can get. So what is the sense of giving me discount when you've already increased the price in the first place? And that is what we just give, justify here. It is not only giving discount that matter, but what about the price you put, you tag in the first place? That's what we mean. Now, when I say for your final model, is the rate of change in sale with respect to price the same for all levels of discounts? Explain. If you want to do this, then you now put into consideration what we did in class. You're going to compute what we call covariate adjusted means. If we want to, you're going to do that for 5% discount, for 10% discount, for 50% discount. Oh my God, where did I get negative 472.9? That is an intercept in the regression model. When I run the Ancover, I'm going to take you there now. I need someone to take a look at the first one. When I run the Ancover, the model.3LM, when I run the Ancover, well, I'm actually going to use the estimate in that column. I'm going to use negative 472.953. Okay, and I'm also going to use the one for price, the one for that, the one for discount and so on like that. But let me tell you this. The one in the intercept, you can see there is 10%, 15% discount. Where is 5%? The 5% is nested in the intercept. That's why it's not showing, right? Now, if I take you back now, I may not attend to question today. I have a meeting, 5 minutes. I'm actually going to stop in 5 minutes. And I may not attend question because I have a minute, 10 minutes from now. Now I'm going to rush out. Sorry about that. Okay, let me see. Take a look at this guy. Now, when you take a look at minus 472, 79, and whatever that you have, if you go back, that will enable you to calculate the adjusted I will talk about. Let's take a look at that now. Negative that, where do I see 79.591? Where do I see 6.822? Where do I see the 11.476? Okay, I'm going to show you now. 79.591. You're going to see that now. Now, do you see 79.591 in the price, the slope for the price? You see 6.822, 11.476. Okay, now you've seen where I got that, right? Okay, now the next thing now is, where do I see 8.524? Oh, is that not like a mean? Okay, take a look at that should be the mean of the price. The mean of the variable, quantitative variable X, they covariate. I'm done with problem 1. Problem 2, because tomorrow, oh sorry, not tomorrow, on Wednesday, it's going to be problem, but let me prepare your mind. On Wednesday, problem 3 is basically going to be something on random effect model. Problem 3 centered on random effect model. Problem 4, centered on two-way ANOVA. Now when you take a look at what I have now, it's just two-way ANOVA, okay, ANCOVA, random effect, unbalance. That is what's actually what the midterm tool will focus on. Okay, this is where I'm actually going to end my review today. Like I said, I'm not going to entertain any question, but I'm going to tell you this before I go. Pick yourself up. Believe that you can pass excellently.